Okay, thank you so much, everyone, for coming to our Agriscience webinar. And thank you so much to our special guest, Elizabeth Proctor, who is a K to 12 STEM educator, is going to talk about what agriscience looks like in her elementary school classroom. And then we also are joined by Timm and Kevin Anderson, Paul being a middle school slash high school science instructor from Lyons Decatur Northeast, and Kevin being a 7th to 12th grade agri-science teacher from Lyons Decatur Northeast. And we'll be hearing from Paul and Kevin about the FFA Agriscience Fair, which is a really cool opportunity for your students. So first with Elizabeth, whenever you're ready.
Okay, so I can share my screen.
Absolutely, yeah. Feel free to share away.
Share. Can we see my screen? Y'all good? You can see it?
Yes, we can see it.
Okay, perfect. Well, I do want to say that I spent 25 years in the high school setting, and the last 10 I spent in biotechnology research and development. And then I did something really crazy and decided to teach the other end. So now I'm starting with kindergarten and first and second grade. So I've been on both ends of the spectrum. I've only been to Wyoming one time, and I do remember the Devil's Tower, so I put that on there. It's a beautiful country. Passed through Nye, Montana, and I think the jail and the grocery store and the restaurants all were in one building, so it was interesting. So I loved my time in Wyoming. Um, these are some community partners that I found in Wyoming and some resources that connect with what I'm going to share tonight. Because these are the same community partners that I have in Georgia. I'm in the South in Georgia. So the University of Georgia has an extension agency, and they come in my classrooms. That's Mr. Derek Jones with the drill up there. And every time he comes to see my kids, he brings a drill. So with kindergarten, we've been doing worm boxes, and so they keep these boxes all year long. We drill them and make them in class. I put the what you need to make the worm box at the top. And then I've got some pictures of the supplies and the books that we use. The Farm Bureau actually donates the books, and the Farm Bureau pays for the materials. So if you're not in touch with your local Farm Bureau or your ag agent, those people are really, really valuable resources. And if you get written into their yearly plan, then those action steps will be taken out in your classroom. And all you have to do is join their advisory committee and put forth your ideas. So if you haven't done worm bins before, it's a really good way to teach kids about compost and soil. At the very end, we empty out the worm tea, which is really kind of worm pee mixed with water, and plants really like that. So there's the jug of worm tea that was collected this year. Um, and then the kids are really good at doing the steps, and that all the worm bins go to everybody's classroom. So the first step is stir, then water, then feed, and then cover so that you avoid flies. So that is the kindergarten long-term PBL. The fun part is they count the worms, they keep a record, and there's stem journals of the worms. And I had a picture on here of a worm egg. It's in the middle. So that's fun too to see the full life cycle. And we have different size worms. First grade's been working on solitary bees. Solitary bees will nest. I brought one box home. This is the example of what we've been doing. But this year I'm going to try and put the straws in because I've not done this before, but you can take the straws out and you can peel the straws open and see the actual life cycle of the bee. The bee stays in a like a hibernation, a torpor for all of winter. And and it makes a cocoon, goes through metamorphosis, and you can pull these out. People will take these out of the homes and then put the straws in the refrigerator to keep them at a temperature so that they go through that hibernation. So all of my students make these. Our local high school kids actually do the drilling of the holes, and the kids in the first grade, they're drilling this on and putting a magnet on, not a magnet, a compass on, because it has to face south. But Mr. Jones comes back with the drill again. Every time he shows up, he has a drill. So the kids look forward to power tools with the ag agent. And then let's see. Oh, there's other examples you can do it with just straws. We're doing this one year two. The wood is the fanciest. We do like the wood box, but you can also do it with straws. I looked, there are lots of mason bees in Wyoming and up where you guys are. They just come out a lot later than our bees would come out. So, but it's the same life cycle. And this is something that people don't think about. Honeybees get all the glory, and they are not good pollinators because they're not buzz pollinators. They don't shake it as good as these other pollinators do. So this is a great way to teach kids how they can help with pollinators in their area. So, and this book, The Orchard Mason Bee, is a fabulous book. I mean, it is absolutely fabulous, step by step, hand drawings of what to expect and how to do research. So that's more the teacher book. Second grade is works on butterfly puddles because our school goal is to attract more pollinators to our campus. Butterflies are pretty disgusting. So the Farm Bureau donated this book. Butterflies are pretty gross. The kids sit, that's Laretha from the Farm Bureau working with the kids, and they made a T-chart, gross, not gross, and everything. Every time they sorted their data based on the book. And then Mr. Jones is over there working with them on the butterfly puddle. And we do put a little bit of cow patties in it because butterflies are gross, and we learned that they do like a cow patty in mixed in there. So it's kind of like you're making meatloaf and you mix it in there, mix the cow patty in. And we divided the class into three groups. And so and I put down there what our three groups did. So when the kids rotated, each group had something different to do. While Miss Laretha was reading the book, Gross Not Gross, Mr. Jones was making the puddle, and then I had the kids dissecting flowers. So your local grocery store throws away flowers when they are past their prime date. So I just went and talked to the local florist, Beth. I said, Beth, what do you do with these flowers? And she said, we throw them away. I said, I would love to dissect them in our classroom. So I have, and she's even given me moms and bulbs, all kinds of things, roses. So if you have not hit up your local florist, that is your local grocery store, it's going in the trash. Now, the funny part is when I taught plant reproduction in high school and I taught the parts of the flower, we get to the pistil. The kids, there's eggs in the pistil. But when you say pistil to a kindergarten, this is exactly what they do. They pop out of their seats and holster up. So, or I tell them to holster up. And then we also participate. I looked for in Wyoming and I didn't see it, but we have a pollinator count that's run through the University of Georgia. And you actually submit data to a statewide database on how many pollinators are on your campus. I put the link here to our pollinator census because it's something that could be replicated really easy. And we keep a grid in the hallway that shows how many pollinators we have been counting every year, and then we go out and do other pollinator counts. So if your state doesn't have one, you can still follow Georgia's procedure, and they put out cute videos on how to do a pollinator count. And then second grade, here's Mr. Jones showing up with his drill again, but we work on hydroponics, and we do it in just 5-gallon buckets. So I put the supplies there for how we're doing that. And the kids cannot use the chemicals because they're just not safe for kids. But I found that the lettuce only raises the pH. So we added lemon juice to lower the pH. So we didn't do any chemicals other than lemon juice. And the and we grew big buckets of lettuce. You can see that we stop at about 7-8 weeks because the lemon juice is not adding any nutrients to the water, and the nutrients are depleted at that time. But we do get a nice crop in the few weeks that we do. And then we also have another community partner, a hydroponic farm. It's called Produced, and we took a field trip there. And he showed me a new method with these rocks and pebbles and stones to use for hydroponics. Um, let's see. Oh, and then my last thing to share is Plant the Moon Challenge. And it's the second year I've participated. My team actually won the first year we participated. We did not win this year. We didn't win this year, but we did win top awards. I had two teams and we won both first and second or first place. But what I was going to show you is Wyoming is not participating. It doesn't look like Nebraska is participating. So this is a really good agricultural project. It's pretty cool. They send you a bag of simulated moon dirt We did moon dirt and we did Mars dirt. And I'll tell you, they turn into concrete. Your rule is that you can amend the soil with whatever you want to. One of the projects that won this year that was the FFA winner for high school, they put human hair in. That was their amendment. So, pretty gross. But you have to use at least 50% of the moon soil or 50% of the Mars soil. It's about $400 to enter, but I have not paid any fees yet because they opened this portal for grants for states to sponsor you. And it's pretty short, and I filled it out, and I've gotten it both years for both teams. And you're only allowed to apply for one team. So what that's telling me is that people are not applying for this grant. And it's a worldwide competition. South Korea beat us this year, and my guess is they're probably fifth graders. They beat my second graders. So that's it. And then they got the statistics up there. But that's it. And the link for Plant the Moon Challenge is right there if you want to click on it. And I can put in the chat, and Laurel can share the link to these presentations in Google Classroom in the Google Drive. And that's it. I know I talked fast, but if you have any questions, let me know.
Thank you so much, Elizabeth. Yeah, any questions from anybody?
Other than, I think it's great that you use the resources locally because I think there's a lot of times we forget to ask our people who are already doing some of this stuff and have that expertise to come in. And I liked the idea of asking the grocery store about getting flowers because resources are always hard to figure out how to get, especially in Wyoming because there's a really short growing season.
I'm curious, could you either show the slide again or just talk briefly about that partnership that you established and what that looked like and how you would recommend folks start partnerships like that for themselves?
Well, we're rural. We're very rural. Maybe I should have said that. I live on a farm, and we are in the middle of Georgia, below Atlanta, below the airport. We're in the central part. Like we have two stoplights in town. That's all we have, and we're very land dense. And students sit on buses for a long time. So at least the ag agent was actually at our house testing our well water. So just knowing, I guess people, a small town kind of stuff, just knowing the ag agent in your community, but you can just walk into the office. A lot of times they share in our area, they share responsibilities with 4-H. So if you have a 4-H agent that comes in, I don't think they come in our state until like fourth grade and up, but the 4-H person would know. And then Farm Bureau, I'm just a member of Farm Bureau, so that's how that came about. And then they wanted to donate books to the classroom. It was, I think it's just small town, just being in a small town and knowing everybody because we only have a Dairy Queen that we call a Brazier, and everybody's at the Brazier. So, but I imagine that small town kind of feel where you guys are too. So,
Yeah, we don't have any stoplights where I teach. Stop signs. I actually drive 40 miles from our larger town of about 10,000 out to a regional area where in the valley is what they call it, is about 1,700 people.
that's beautiful. Yeah. Well, I don't know. I looked. It looked like y'all covered the ag agents or the extension agencies covered all 25 counties, but I don't know how land dense those are and how that is. But I put their websites, their links on there. Um, but
Well,
I don't think I answered it, but that's really how it happened. So
I like that you said 4-H. I was asked to teach a computer science part this summer for 4-H.
mhm.
And so you've got me thinking I should talk to the other parts and people who are working in the 4-H and talk to the extension office and get some ideas from them and find out what other experts are there that I just wasn't aware of. So
Yeah,
thank you.
yeah, you're welcome. And the Farm Bureau is very politically active nationwide because they sent me to a Women in Ag conference in Savannah. because I don't know if how many people are getting in touch with this. So you kind of get on like an email list, and and the Farm Bureau, like they just sent a grant last week for $500 to do agricultural outreach in my classroom, and they sponsored about $100 a project is what my local agency was doing, and they sponsored a couple projects this year. So I do think that the Farm Bureau has funding for education, and I know that the books are nationally sent out. So whoever is getting those books should have a contact person.
That's great.
Yeah. I don't know what it looks like in Wyoming. The Farm Bureau, they've got some programs in Nebraska that they work with elementary classrooms. They do a lot of it through the FFA and that. We're a part of one of the projects, not research based, but the Farm Bureau deals a lot with agricultural literacy. Have some great resources and those things across the nation.
Yeah, we do have our school does some of the FAA projects and programs, which I'm learning that 4-H and FAA do similar tracking together, just I guess the age and whether they help in the schools or in the community, I'm finding. So thank you. That's good to know too.
Yeah, it's really great to learn about all these resources. I'm learning about these resources myself too. So thank you so much for sharing about them. I'm also curious to hear from you, Elizabeth, about where you feel that your students are engaging with building invention or research skills through doing these projects.
Well, for the bees, that's simple because it's all about temperature and where it's placed and humidity and height and about north, south, and just reading a compass. And then when we start with these straws, we're going to see which they do have a particular diameter. And we've also, once we learn how what this looks like when it's packed with mud, then we can find it in the garden. And we've been breaking the butterfly bush's stems at odd, and we didn't, the kids are not noticing that yet, but it's after years of doing this because I see the same group of kids for multiple years. It's only my second year with the babies, so but I do think they'll catch on ways to build other designs and where we can put straws. And then with the hydroponics, that's definitely some engineering going on there because we have a bucket company and we're very, very rural, but one of our industries is buckets and we have a bucket manufacturing. So they don't, that's one of the reasons we're doing hydroponics and buckets because we have access to buckets because when they change the color, when it goes from green to brown or whatever, you have that muddy bucket, and they'll share those buckets with us. So that's a lot of engineering on how to figure out what size hole to put in. The baskets come in different sizes. The rock wool comes in different sizes. You can put different size aquarium filters, motors, different types of bubblers. So we've set up different types. We've also put it next to traditional farming, like we'll do whatever we're growing, we'll grow it in a traditional way and compare the growth. So there's a lot of ways that the littles can think about in their world and do their own adjustments. That's why the lemon juice was important. That took a minute to figure that out because they cannot use those chemicals, but they have to sustain the pH or it will die. And they don't understand what pH is, but we use a lot of pH paper and put it in liquids in those little tubes you were talking about, those centrifuge tubes. Because I also am networked with it's called Georgia Bio. There's probably a Wyoming Bio. And what they do is they're a nonprofit and they surplus all the plastics from your pharmaceuticals or your hospitals that aren't used. Are brand new and you go and pick them up. So when you were talking about those little cap tubes, I have thousands of them in my classroom and they're free because they'll change their machinery and they donate them to Georgia Bio and then Georgia Bio lets teachers come pick it up. And I didn't look to see if there's a Wyoming or a Nebraska bio, but I think they're in every state, and their goal is to kind of reduce waste, pharmaceutical waste. But you can get a lot of test tubes for free. Sorry, I know that's not the direction we went in, but I did teach biotech for a long time.
No, that's
And
amazing. Share all the tips and tricks.
Amber,
That's great. And it's
you
always
can
wonderful to hear ways to be able to find things at l low to no cost, right?
no
So
cost.
that's great to share for sure.
You can do the same thing you did with strawberries with spit, but you just got to get a meat tenderizer from the grocery store and some salt. It will because the detergent's breaking down and the meat tenderizer will break down the protein. So you can do the same kind of lab with their own spit. But if you Google it, you will find it.
Yeah, Google is that great resource. No, it's actually everything. Since I teach physics, I tell kids that's how everything works. And so I try to throw every life science, chemistry, whatever, tie everything and anything together. And so any resources that can teach, I'm game for, especially if they're free.
Great. Um, Thank you so much for sharing all of this, Elizabeth. Any final questions for Elizabeth before we shift to the next part? Okay, then. Paul and Kevin, would you like to take it away and talk with us a bit about what the FFA Agriscience Fair is like and any other tips and tricks you have for doing agriscience projects with older students?
Yep. Paul and I, it was the last day of school was yesterday. I spent today at the state track
Oh,
meet. So this
jealous.
is not rehearsed by any means. I'm just gonna preface that.
Well, and if I might, Kevin, if I might speak just a little bit into just ag education in general, and
Yep.
then um, when you first contacted us, Laurel, I part of my training, I originally went to school to become an ag education instructor and taught for 5 years before taking my second endorsement and going in to teach the biological sciences. But ag education, and let me ask Amber. Amber, do you have ag education at your school? Do you have an agriculture education instructor?
We do not in middle school, but at the high school, I know that they do more combination with the FCL, and I always get it mixed up. Future Leaders of America, that kind of, I always mess up the acronym. But yeah,
Sure, and there's a lot of them to remember.
yeah.
So,
And
um,
so yeah,
I
they do that and work in the schools and get the kids to do the programs, and then they go to the fairs and all things throughout the years. Yes.
Well, what's so powerful about this right now? I have the saying, all good things follow good relationships and good ideas. And with what Elizabeth has shared and what Laurel and the society is doing to create those relationships, but also share these ideas and explore opportunities um, that some people may know about, but others may not. Agriculture education is very powerful, and it overlaps very well with the science classroom in that as you take a look at the three overlapping circles of what ag education is, which is classroom instruction, it's supervised agricultural experience program. So every student that is in ag education is striving to develop career skills in a variety of areas, whether it be entrepreneurship, placement, or whatever. But you're developing skills that are employable skills that they're increasing in proficiency and competency in. And then the third circle is FFA, the National FFA organization, which gives students a chance to not only compete with various contests in the skills that they're developing in their content knowledge, but when it comes to the programs that they're doing, their supervised agricultural experience programs, whether it's an entrepreneurial business or doing research, ag related, that over the span of building a portfolio of research, seventh grade through senior year, research is not a project that goes to a fair. Research is a continuous process, right? And that's where I think agricultural education overlaps so well with doing research because as you look at the science classroom and the next generation science standards, what are we focused on? core disciplinary concepts, core disciplinary ideas, cross-cutting concepts, and then those practices, those engineering and science practices, which when you overlap those with what Ag Ed is doing, it's a very powerful combination. And so I would encourage you with the great things that you're doing already to get kids doing research and exploring their ideas and their questions. Definitely reach out to that agricultural education instructor to see what he or she may be doing and seeing what type of partnership might be able to be developed. Because the reason why I invited Kevin here today, we've been working together, but Kevin has been doing such an awesome job with our agriculture education program. And Kevin, how long have you been doing agri-science projects? What year did we start this?
I think this was either year 12 or 13, somewhere in that vicinity. I meant to go back and look, but somewhere we've been doing it a little over a decade.
And so as we've kind of paralleled and worked together, how do I ensure that my students that are doing research projects are also able to have them overlap with ag education or vice versa, so that in both spheres, at both sets of fairs, they can be reaping the benefits of being able to share their research, have a research mentor, be growing in their skill development, and then receive those awards accordingly, whether it's ISEF or whether it's the National FFA Agriscience Fair. It's been a really exciting journey, and so it's at this point I'd like, Kevin's the Agriscience Fair expert, or at least I trust him in that because it's hard for me to keep track of all the rules and how they change every year. But he's prepared a presentation, Kevin. I'm going to let you go ahead and take her from there.
All right, I'm going to share my screen this presentation because I didn't know who was all going to be in the room and that some of it uh maybe more why did I get that? I got the little exclamation mark of death. So
Uh,
let's see what happens here. Yes. Working to get past that. Where's it at? Don't do that. All right. Well, sometimes our tech guy here at school puts permissions on things that I used to be able to share my screen. Well, anyway, I'm just going to talk because there's nothing I don't have neat graphics from Wyoming like Elizabeth did and that I have been to Wyoming more than once in my life. I was there last summer actually. So um anyway, from the Agri-Science Fair and I'm just going to start with just the why we started here in Lyons and Laura, I can share this presentation with you so you can put a link to it and all those other things. And I'll do that here after I talk a little bit. But
is it
you know,
sharing?
as what
Is it sharing on the screen now?
Yes.
it
So
is?
Kevin, you can talk and I'll run it from my end.
Okay. Awesome.
I got it
Okay.
running from my end.
Sounds good. Skip to the third slide.
You bet.
Awesome. How'd you get around Jeff's filters? But
Didn't even have to use the admin password.
so anyway, currently, and I'm going to talk a little bit. Currently, this is the way the Agri-Science Fair divisions are set up. It can be either an individual project or teams of two, and they're grouped by grade levels. So seventh and eighth graders are division one and two, then ninth and tenth, and then obviously juniors and seniors. The current what will be for what we call the 2025 and then 2026 award year. So next year, this is the setup for it. Uh, Go to the next slide, Paul. And in these categories, animal systems, environmental, natural resources, I'm not going to read them all to you. And so they can be uh, very experimental, research based. They can be correlational. We're allowed to do survey type things. Those typically fall under the social systems. They come into preferences. To give you just some ideas of things that we have done, animal systems, we've done anything from, and I'm going to tell you as I start this, our beginning projects, I worry a whole lot more about setting up research design. Now, from where we started this, Paul is now doing a lot more in our junior high than we're done previously. So students are coming in with a little more base knowledge than they were 10 years ago. But I focused a whole lot more, and I still do, on the research design as opposed to doing what I would call high science, because I want them to do science well first. Then we can get to higher levels. And like I said, with the work that Paul's been doing with our middle school here recently, there's a lot more of of that base knowledge coming in. But when we talk about, animal systems, we've done anything from different types of music, color blindness. One of the cooler ones we did there was, can a producer's visual acuity determine lameness in animals? So we had a producer visually score soundness, structural soundness, and then we were using pigs, ran the same breeding gilts across force plates and measured the amount of force on each individual limb, and then determined how accurate was a producer's visual acuity. On the plant side, most of us have dealt with plants. We've done lots of fertilizers, fungicides, uh, uh, root colonization, inoculating with bacterias. Uh, One of the neat things, I had a student once that actually carried it through, and he was actually doing field trials on one of his dad's piece of land with a fungicide that they were looking at doing. I love to tell that story, and then I say that in mid-June, a hailstorm completely wiped out his entire research. So anytime you do field trials, um, there's a few things that don't always go the way that we would like them
Yep,
to.
some risk. Yep.
Um, and that a lot of the natural resources, environmental ones end up being a little more longitudinal, but a lot of water studies. We've done a lot of things with water into that area. Uh, Plant animal power structure, anything from building materials, structural strength of welds, those things, food products, and without getting too deep into the woods, in order to fit the food area in the Agri-Science Fair, you have to do something along the lines of changing in manufacturing, the preservation, some things like that. Parents always love it when students are just letting mold grow on a block of cheese in their room because we're looking at different preservation methods, uh, and those things, or the classic, let's buy some cheeseburgers from different fast food restaurants and see which ones don't grow mold after 2 weeks, because one of them didn't grow mold sitting on the counter for 2 weeks. Not sure what they're all preserving it with, but they're preserving it with something. Uh, and that we can also, in this, then on foods, and it's kind of, you get to the social systems, you get different consumer perspectives, so taste tests with food. We've done perceptions, and like I said, we do a lot of surveys on in this area. Student perceptions of animal welfare was one of my favorites. Roughly about time we were starting this, our school was actually considering a merger with two local school districts. I actually had two students survey students at the three schools and what they felt the impact on the ag education program or programs would be. And so that social systems for that kid that maybe isn't necessarily really into experiments, gives them a way to collect data, and analyze that data and the differences and those things. So those are the categories. In the Agri-Science Fair, you got to make sure you end up in the right category. Okay, I should say, at least in Nebraska, we don't change categories once it goes there. So if you entered in the wrong category, it's in the wrong category. Nationals is the same way. I'm sure every state does things differently. Georgia has an amazing Agri-Science Fair program going on down there, and everything that Georgia does down there. Met and worked with a number of teachers from down there, and everything they're doing. They were ones that really jumped in this program very early in Georgia and do some amazing things down there. Uh, then of course won't mention that the one school that I was working with was six ag teachers, and five of them have PhDs, and I'm teaching in a town of 849 people. There's some apples and oranges, but we have a lot of fun. So, and so Paul, go ahead and click down.
You bet.
Uh, the 2027 award year, this is all changing. So that's why in 2027, so not this coming year, but the year after, the divisions are merging to be teams of 1 to 3. So there's no more individual and team. And so there'll still be the 3 age divisions, what I call junior high, and then 9, 10, 11, 12, but there's not going to be a separation between a student doing individual research and a student doing team research, um, as far as that goes. So that's coming down the pipe soon. Uh, I don't think it's going to affect it the whole lot. They rolled out some changes about a year ago that were going to drastically change this. They've walked a few of those back. So that's really the big change on the Agri-Science Fair side that's coming down the horizon. Uh, and then just some places, the Agri-Science Fair handbook, make sure it's in the right. And we do have a required template that I know sometimes, and Paul mentioned the kids that, bounce around between NJAS, ISEF, Agri-Science Fair, and those things. Uh, just making sure that they meet whatever each of the different fairs requirements are. Because I know this one trips up a number of students and teachers in Nebraska because they want to plug and play. They did this in biology class, and now we want to plug it into the Agri-Science Fair, which is great. And I love working with Paul. I love that cross curriculum and ag students seeing that the basic sciences aren't as boring as they think they are. Sorry, guys, but also that that there's some really fundamental science principles that we're trying to get across to them in in agriculture as well. So then go down to the next one. I get asked a lot, why did we start it? I've been teaching, I just wrapped up 26 years, so roughly about halfway through, we took the leap into this, and that and my reasons why, and if you're working with an ag teacher in your school, or later on if an ag teacher's watching this, and why did we start it, it gets harder and harder. Our students, even in rural communities, there's not as many that have the opportunities for that traditional SAE, for that traditional out of class experience. And so it was a way for me to make sure that every freshman, I incorporate this into my freshman class, um, at least started in SAE. Some students continue research for 4 years. Some, Mr. Anderson made them do it their freshman year, and that was enough, and that's fine. They had the exposure to it. They could make the decision whether it was something they liked or not. Um, and so they could start it. It could be their interest. It didn't matter if it was plants or animals or welding or electricity or like I said, some of the social systems, uh, and that. So it allowed every freshman to get involved with that three-circle model. Um, the way, I mean, the way I implement it in that freshman classes, I'm sure the way that everybody does. There's a deadline approach. You need to have this done by this done by this, and then if anybody's got great ways to tell me once you start collecting data, because some kids they do a survey and they have a 1 day data collection and they have 800 data points, and other students even on a root colonization study we're running for a month collecting data and those things and so once we get to data collection, deadlines are more like suggestions until we get to the the final big one. um and
Well, and
those
if
things.
I can chime in here, Kevin,
Absolutely.
one of the most challenging paradigms I think any research teacher faces is getting kids to exit project brain and enter research brain. Project brain tells a kid there's a finite, I'm done, and then I can forget about it till research time starts again next year when I start my next project. Um, a project at rest remains at rest. A project in motion remains in motion. And so by being able to team up between our two departments, as those kids that are working on their agri-science projects are also exploring things that they could be taking to our regional ISEF qualifier or be taken to state science fair. You're always talking about, okay, what questions are you setting on the shelf that we can tackle longitudinally at the same time, or that you're going to take off next? What questions developed as you were tackling this one? And the SAE within ag education provides the perfect model for kids realizing you don't project an SAE. An SAE is a continuous program that through the summer, when's the best time for kids to do research? In the summer, when they're not juggling 7 classes and college AP exams and things like that. It has been powerful with our situation. We can attest to one student in particular that he was a two-time ISEF qualifier and won the top award in FFA in our state in agri-science for the research that he did over 3 years. That was a prime example of what we try to communicate to students. Not that we do it for the awards, but we do it for the discovery, we do it for the growth, we do it for the mentoring relationships and the skill development that leads to future careers in the STEM industry. And that what is that student doing right now? He's in his fourth year as a professional, setting up research studies for livestock producers throughout the United States, so that he can collect data on their methane production, and help them to become profitable while making their operations more green and environmentally friendly. That's his job now. That right there is exactly why we do what we do. We're trying to give students the traction and moving forward, not that this is a finite, we start and stop, but this can be your future. So go ahead, Kevin. I'll turn it back to you there.
Nope, that's it. That's exactly right. And we all know it. Not research isn't for everybody. It isn't as much as the benefits of it. I think it's really good for them to have the experience of it. Uh, for some students, it continues on. For, like I said, some they're done. If we want to go to that next slide, like I said, some students continue on. Okay, that was my deadline. Summer's a great time for research. Hey, there it is on the screen. And I mentioned this earlier, especially a beginner, and you know, there's a big gray area between challenging a student and scaring them. And I'm going to be completely honest with you. The first year that I put this in my program, like I said, it was a huge shift in my freshman class. I was a little worried how many were going to drop my class. Um, just not that it was overwhelming, and that group had tons of success through the years. One of them ended up, Paul mentioned the Star in Agri-Science that one of our students have won. One of that very first group ended up as a state finalist, didn't end up the star, but there is a big gray area between challenging a kid and scaring them. really focusing on the experience. One of the things I like about it too, because you can so tailor it. Um, I can have the valedictorian of the class, and I can have the kid who reads at the third grade level in the same classroom, and they can both do research at their level. I remember a student, he was a TBI kid, um, did the greatest research on microwave popcorn and which one popped the best. His family ate a lot of popcorn that week, but it was at his level, and he measured and he did the data, and that was, definitely not high science, but it fit that kid so well, and it was cool to see him be able to present that and do those things that a lot of times we don't think when we think of science fairs. And yes, we all love banners and trophies and medals and plaques, and we love the kids that qualify for ISAF and all of those things, but sometimes we can't forget about the impact we can have on the other students that maybe aren't at the very, very top of it.
Which is why in junior high I require every single student to do a project, and that Kevin, every one of his freshmen, does a project. We believe in what it does transformatively for kids.
Yep. So that's really the presentation as far as that goes. I have some other slides if there were specific things about rubrics and stuff like that, but that can all be found there. And so, what questions, thoughts, worries people would have?
I have a question about have you ever had kids, or I guess how to not temper exactly is not the word I'm looking for, but if they take a bigger bite than they can deal with, how have you sort of guided them like, whoa, that's like let's save the world from, I don't know, whatever. How do you guide them into making sure it's not too big of a project to take on?
Yep, and that definitely, and you want kids to dream big. Yeah, you absolutely want them make the impossible possible, but in reality, in the educational world, there are things that are impossible. For me, it's having that conversation with the kid is okay. That's your end goal. That's your end result. Um, Here's the time frame. Here's what we have. What's a piece of that we can do? And then, and as Paul alluded to, as you build on it, maybe their dream is something that's 10 years down the road, but what are those pieces and those chunks of that? I mentioned the kid who ended up doing field trials and those things. I mean, he wanted to do that his freshman year, and I was like, that not gonna happen not gonna happen year one. And so we actually did with the same fungicide in that, but a study with the grow labs on spike to five. So if the first five vegetative stages of corn, so in the production world, spike to five, and its impact at the very beginning, to where then at the end he could start to look at a yield. So what I try to do is let's find that one smaller chunk that we can do while you figure it out, and then maybe it builds out from there. Some kids always have that dream beyond, and sometimes kids find I had a kid do some biofuel research. Paul's gonna remember this kid that um he ended up finding people from around the nation to send him seeds to extract oil. He had seeds that I was like, where in the world you getting this? And he figured out how to find it, and that was his second year. It wasn't his first year, but sometimes the students will find a way too when they really get into an idea. But I guess for me, I try to find a chunk that we can do, and then build on. I don't know, Paul, if you've got anything to add to that.
I use the comparison of the mini shot glass project versus the whole chalice, and I guide them down. So it's so hard to keep them from getting into project brain. Like you should not have an idea totally of what it's going to look like in the end, unless this is an engineering project where you have criteria and constraints, right? And so what I do to help the kids narrow it down is I ask them, I tell them, I want you to find a topic you're interested in, not a specific project. Do you like food? Do you like cattle? Do you like machines? And okay, write me 30 questions. What are 30 questions you have about AI? What are 30 questions you have about exoplanets? What are 30 questions you have about drones? And then after they've written, because any kid can come up with 15. It's a little bit of a challenge to get to 30. But then after they share that with me, I say, okay, you have 2 days. Come back and I want you to find me answers on all 30 of those questions, and I want you to teach me about your topic. And I say, you're going to get frustrated. Some of them you may not even find answers for, but I want you to give me your best effort for 2 days. Come back and show me what you have. And so we just start a dialogue back and forth, and they'll find 20 of those questions, 22, 23 of those questions, but there'll be seven that they don't. And I'll compliment them. I'll say, those seven, okay? Now you just learned a whole bunch of stuff up here on these 23, but these seven, science is looking for the question we don't have an answer for yet. That's what we're looking for. And in the meantime, you just learned a whole bunch on these 23 and you taught me. Now, did any more questions come up? Could you give me 10 more after you learned on these 23? And eventually we get to a point where we find that question. And I say, okay, we eventually have to commit. We're going to marry our project here, and it starts with finding a question. We're going to commit to that question, and then we're going to find within our doable time period, what can we identify as our independent and dependent variable, and that starts us down the right road of, okay, what can we measure? What can't we measure? What do we have for resources? Who do we need to contact? It gets them narrowed in enough that, rarely is it that we find something that we absolutely can't tackle. And I'll be straightforward and honest with those kids. I'll say that you're not going to be able to do that. And here's why. I love your curiosity. That's how I try to keep them from getting too big, trying to digest the whole cow instead of taking one bite of the steak.
I like that step by step kind of way to let them also come up with the idea and find their own way through it.
Well, and it really, Kevin alluded to, you'll get the valedictorian kid, and you'll have a kid that has a third grade reading ability, and they're in the same class. But this kid can be just as curious as this kid. And quite frankly, what I've discovered is sometimes it's the D plus student that is the better research kid than the A kid, because the A kids, they know exactly what they need to do to get an A, right?
Yeah.
But the problem with research is we don't know where it's going to end. And we have to trust that. That's very uncomfortable for a type A student personality. But the harebrained kid that has some wacky ideas that maybe isn't real great at getting hundreds on every assignment, they'll have some great questions and sometimes some follow through work ethic that really surprises you in a good way.
You also, we have a smaller district, and so our 6th through 12th grade science, we basically kind of plan out and work on our from 6th grade to 12th grade how we're going to develop science skills. Do you guys also have other teachers that work with you on this, or is this solely something you guys do in your classroom?
Are you speaking to Kevin and I?
Well, I
Either,
would
yeah, yeah, either
from
any
my
of you
standpoint,
actually.
yeah, from my standpoint, I'm a single teacher program. So what runs through the Agri-Science Fair um, is me, and then the partnership with the research program that Paul has built and continues to build. And if there's a student who is an FFA member and research and their project fits the Agriscience Fair. Um, Paul is our life science teacher. We've got another science teacher. I'll let you talk about the general science curriculum, Paul.
So we do have a second physical sciences teacher that has jumped in full force with so this past year was the first year he taught eighth grade science. I've taught 7 through 12 everything but physics and chemistry since I came in 2008. But this was the first year I didn't have to teach eighth grade science. And so we were able to substitute in a second class period for research for high school students, which in a small school, scheduling is everything and it's very inflexible because you'll have one section of every elective, right? So, which makes it very challenging. And so through partnering and looking for those opportunities and seeing what people can support, and also our administration and our community seeing kids benefiting by multiple departments and programs working together, it has become a good kind of a collective effort. This upcoming year is going to be the first year where our ninth grade English teacher, Kevin, I haven't shared this with you yet. He's going to be assisting with the background research as we're learning how to conduct background research, write bibliographies in APA format. How do you do that? There is a English standard that has to be met for freshmen that we're actually going to kind of cross cut and work together in helping kids learn how to do that so that they will not be starting that in my research class cold turkey. So
Yeah, because we're in, and small is always a relative term. We're pre-K 12, basically under one roof type of school. We graduated 22 or 23 this year, Paul. You know that better than me. My older two are a
great.
little bit older and they graduated with 11 kids each. So we kind of all know each other around here.
Well, and the reason I ask is because I've noticed this is only my eighth year teaching, almost done with the eighth year. And I just found it very helpful when we kind of changed some programs and we were able to talk to K through 5 and see they wanted to know what I needed the kids to do to build upon it, to help them build. And then we middle school or secondary teachers meet regularly, more regularly than we do with the elementary. And so we know specifically what we're going to hand off a little bit better than I think sometimes the elementary does. But it is nice that you can actually talk and collaborate because it's like handing that baton over a little bit more. So it's kind of nice to hear that that's what you've developed. It almost sounds like naturally, or at least you said the relationship building is really important through like the educators. Because I find that sometimes I want to do some projects, but nobody's going to pick it up from me. And so again, I'm handing it off, and I've looked to some other teachers, either in computer science, which I also teach, or any of the other projects that you want to do. And that's why I kind of like, well, I could build this up for you, but I don't know if you're going to get beyond the basics.
Well, and never underestimate the power that's in community partners too. Like what was showed in your presentation, extension. Oh, they're wonderful. And if they can't help you or can't answer your question, they'll have a network of people they can contact to find that right person that might be able to speak to that particular kid's project or to the particular thing you're trying to address in your classroom.
I want to chime in just a second because I had ISEF qualifiers and we did a lot of research. And one of the ways that in a small town you got those community experts was the local newspaper, which I know sounds crazy, but they'll print anything. And so my kids were superstars. Like we were, if you made we only made the front cover top fold one time. We would make the bottom fold a lot, but it's the car accident was on the top fold and the paper comes out once a week. So, because there are a lot of people that live in rural communities that are highly educated and commute out or work online, especially since COVID. And so we got so many experts just because we were bragging on ourselves on, now I don't have Facebook, but the school does, and they would put things out. So I do think that we're at disadvantages for our children because they don't see industry, they don't see STEM professionals. But if you kind of have to bait them in, you have to get them in there and get them hooked. And we're at an advantage because small town talks.
Mhm.
Yep,
And
and
good
I
job
echo
doing good job doing ag fair. And I loved your ideation, Paul, of getting them to do the 30 questions because ideation was always the struggle. Oh my gosh. So I really liked that. So that was good. And then it sounds like I just hear so many similarities when I'm listening. Because we're K2, but we're in separate buildings, but we're within a mile of each other. And we are very pretty, I'm sure y'all do this too. Don't you take your high school and middle school kids down and then you take the little ones up? Like they move around, they get to know each other. So some of these projects that we do that are long-term PBLs that we were doing at the high school, we took them down to the little kids and they were collecting data too. So it's kind of like you're training your little scientists, and that's one of the reasons I went down is because the metrics say if a kid doesn't like math or science by third grade, they're not gonna get hooked. So I'm doing my own little experiment and brainwashing babies that they are scientists. But good job.
Yeah, there's a lot of similarities. Because I haven't talked to many other teachers more like local that have smaller schools. We have a K-8 building and then our high school's separate. And it would be nice to do a few more things like that a little more handing off, like I said, the baton and getting somebody who could just build off of what somebody's already planted the seeds for is what we usually say. Plant those seeds and the rest of us try to make them grow.
Well, I've interacted with teachers that teach in Brooklyn research, and I've interacted with teachers in our scenario where it's the graduating class was 10 kids, and every community has a strengths and opportunities in building that culture where kids see themselves capable and curious, and that they have that support behind them. They'll thrive in whatever environment they're in. So it's just identifying what are those things and what can I do, what can I do, and but yeah, getting their faces in the paper. Administrators love that, and that will lubricate the wheels a little bit for you.
So many amazing ideas and such great wisdom. I'm just echoing, I love the ideation that you talked about, the 30 questions. It makes me think of an activity that Caitlin, who used to work for the society, talked about with her I Wonder, where she would do those I Wonder journals where students would write down the questions that they wonder about every day. And just getting them to think of questions is such an important part, but it can be a really challenging part if they haven't had practice doing that. So that's really amazing. I love also all the great points that you made, Kevin, and you also did as well, Paul, about how to not have any preconceived notions about who is capable of doing this type of learning, and how there's so much benefit for all students to engage in this, whether they're winning awards or not. And so I thought those were really amazing points as well. I just have one quick question that I'm curious about, particularly thinking about Amber teaching sixth grade students. I know, for example, for ISEF and ISEF affiliated fairs, students can submit research that they've done anytime in the previous calendar year. So as long as it's not before January of the previous year, before ISEF, is there something similar for the FFA Agriscience Fair? So if Amber were to do projects with her students in the springtime, I'm just using it as an example, Amber, but hypothetical, in the springtime,
Yeah.
and then they were seventh graders for the next fair, would they be able to use that then?
Basically the and I have to double check this, but for almost every FFA award or award area like this, It's anything done since the last qualifying fair. So, for instance, in Nebraska, that's our state FFA convention, which is in April. So, things done after that can then roll into the next award year. And that's kind of the general for FFA. It rolls into the next year. So some state conventions aren't till July, so then their mark would be July. We're early April is when ours is. So it all kind of it's when your last qualify when your previous qualifying event was.
Got it. That makes sense. Thank you. Um, any final questions? I want to acknowledge we are past our original time, so I want to honor y'all's time as well. But any final questions, thoughts?
I'd just like to say thank you for your expertise and knowledge and imparting that to me, because that always gives me inspiration to kind of like what way to go, no matter where I go, end up going with it. Because I like to take all the great ideas and pass them on to my students if I can. So thank you guys very much for all your information.
You're welcome.
And I'd say as far as the people on the call right now, it's preaching to the choir, but I know for me it was like taking that leap. I looked at doing it for a couple years before I took that leap of all right, here's something that we're going to commit to. And it's been a great experience for us.
Great. Well, thank you so much, Elizabeth, Paul, and Kevin. We really appreciate you taking the time to present all of this amazing knowledge and wisdom to us. And definitely we'll keep in touch. And I'll be sure to share not only this video, but also the slides if you send me the link for that. So thank you so much. I hope you have a great rest of your evening. I'm going to go ahead and stop the recording now.